Hi everyone, welcome to MLH, and this is our MLH Fellowship final submission as a holiday planner. My name is David, and this is my team.
My name is Jhanvi.
Hi, I'm Adarsh. I'm going to be talking about our project overview. So for our hackathon submission, we built a web app that makes it easier for people to plan their holiday trips. With an easy-to-use flight search and soon-to-come hotel search, users can quickly find hotel accommodations for wherever they plan a visit. By eliminating the need to use multiple different sites, our web app relieves the stress of planning vacations so you can avoid the hassle and spend more time enjoying your holiday. I'm going to hand it off to Jhanvi now to talk more about our tech stack.
Okay, so our tech stack for our front end, we use HTML and CSS with Jinja templating and Bootstrap. For our back end, we use Flask and Postgres. And we also Dockerized everything and automatically deployed it on AWS. So that's our tech stack. Moving on with our demo. So as you can see here, we are right now on our home page, and this is what our home page looks like with a banner and just a footer. Moving on to the main part of our app, that's like the flights page, is where we can search up one of the flights. So I'm gonna put in Toronto to London, and we're gonna just take it for the 27th and coming back on September 2nd. So when you click the search now button, so one thing that you can see here is that we have nothing displaying. So after completing the search now button, we move on and we can see an available flights tab pop up, and we can see two more flight cards, which basically shows all the details for the flights that can be booked. When we click on this book now button, it redirects us to the Skyscanner website for those particular parameters that we had entered in our search bar. So this makes our app highly usable. Moving on to the contact us page. On the contact us page, you can see a detail about the three of us, like a short description. And we can also see a general contact form, which allows you to contact us, and the footer again. Moving on to our sign up page is where a user can register to be a part of our holiday planner website. And here, if I'm just going to register a new website, a new user named Jhanavi 5 and with a simple password. After we click register, we are redirected to the login page where I can sign in our user. And after clicking login, we are redirected to this dashboard welcome page, which basically will then be implemented later on to have like a calendar API integrated with our website, which will allow our user to book the flight and add it to their calendar directly. So this is what our future extension is going to look like. We also plan to integrate the hotels endpoint with this website, which is basically going to be on this page so that you'll be able to access like hotels for that location, maybe some food and life for that location, some car rentals, and general traveling options. So this is how we plan to upgrade our website. And now I would like to hand off our demo to David, who will be walking us through our backend.
Thanks, Jhanvi. So now I will go over how we deployed our application using Docker. So one of the first tasks for our group was to containerize our Flask application as well as the Postgres database. The team can just run Docker Compose up and be able to visit their local host 5000 without having to activate the pip environment. So this is our Docker file. The most important part here is our web application. You can see that it's actually building from our local Docker file, which is pulling a Python container image and copying everything in this folder and then running that using entrypoint.sh, where we actually distinguish between dev environment and production environment. In production, we actually run the Flask application through GUnicorn, and when we're just developing locally, it is actually just running a Flask run, and we can see all the changes locally without having to restart Docker Compose. And then, of course, we have containerized our database, and to make it work, we will need to have volumes. And also, it is on the same network so that both of the containers can resolve each other using Docker DNS. And also, the webcap application depends on the database container to be up in order to serve that file. So that's how we implemented all of our containers. And of course, I'll go more into detail about our monitoring containers. And one important thing to note is we chose not to implement Nginx as a container, and rather Nginx is just implemented on our CentOS machine. So now to go over our CI/CD, as you can see here, we have set up local YAML files for our GitHub action. We have two, one for deployment, basically taking our environment key and running Docker Compose. And similarly for our linting, we are running two tests. One, we're running the black linter, as well as a Docker build test. Another key feature here is we do run a production test over here. If this test does not pass, our Discord will notify us of server failure, and we'll be able to look at any deployment that has failed. Yeah, so now on to monitoring. Our web application has 3 monitors. We implemented cAdvisor, Prometheus, as well as Grafana. All of them are on the same Docker network as previously mentioned. Here we also have a volume specifically for Grafana, just so it can provide all the graphs. And I will demonstrate it here. So we were able to secure our cAdvisor here at holidayplanner.tech/cAdvisor, and everything is working properly when it comes to all the containers, as you can see here. So we have configured our AWS firewall to allow TCP access for port 3000 and as well as 9090, just to allow us to access Prometheus and Grafana. So this is our Prometheus that's running on the same container. As well as over here, this is our Grafana container. Here is the graph that we have built for our monitoring tool. It just shows simple network transmissions to see if anything is overloaded. We also have the web containers CPU usage and database usage. If the database is running at a high level, then we'll be able to troubleshoot as well. Here we also have a brief breakdown of all the memory usage, and that's it. This is our project. It's a flight scanner API that's fully continuously integrated, linted, tested, and monitored on AWS, as well as GitHub Actions. Thank you very much for taking your time to look through our project. We had a great experience throughout our MLH fellowship, and thank you again to the team.